All right, so here we go. Shh, you are going to need your calculator. So we're going to talk a lot about things, listen up, that we spoke about before, right? Didn't I talk a lot about special right triangles before? And some of you were like, huh? Because you forgot them from geometry and from algebra 3-4. Okay, so we're going to talk about them again. So if you're having trouble remembering sine, cosine, and tangent, do you remember SOHCAHTOA?
No.
Okay, remember this. Some old hippie caught another hippie tripping on acid.
I've never heard that.
Although I would never suggest that happen. We're talking about hippies, which would be your parents.
So I just got that.
Good job.
So see, you like that, don't you? Some old hippie caught another hippie tripping on acid. I love it. Okay, so that would be, it's important to understand how to spell SOHCAHTOA, and so that's why some old hippie caught another hippie tripping on acid is helpful in learning how to spell
Miss
it.
Murray wouldn't say it, or not Miss Murray. Miss Washburn wouldn't say it last year.
She wouldn't say that?
No. Well, she said it, but she wouldn't say acid.
Tripping on academics. Apples.
She's like, you can figure out what the last one is.
All right, so we've got sine is opposites over hypotenuse, right? So here's your sine. Your cosine is adjacent over hypotenuse, and your tangent is opposite over adjacent. So that should be probably one of the first things you write at the top of your test. Not that you'll think you'll forget it, but when you take your test, you're going to have so many things that you do have to remember that you just want to get that out of the way, right? So that you can just go back, let your brain do less thinking, and go, oh, SOHCAHTOA. All right, so again, I've listed all of those here, right? And aren't these just inverses of each other? Right? All right, so let's get into some problems. Find the exact values of the 5 trig functions of theta. No calculators. So Sabrina wanted to know why we had to write in, pi over 4 every single time. Because when you get to this type of problem, now we have to write in theta. So if I'm doing sine of, I don't know the angle, theta, right? And then cosine, tangent, equals. And what's the inverse of sine? Don't look. Cosecant, secant, cotangent, equals. So what's the sine? Well, first of all, is there an issue here? Well, you can't find sine yet, can you? No calculators. No calculators right now. What's wrong? You're missing a side. How are you going to find that missing side? Very good. So I'm going to let this be A. You could let it be B, right? What can't you let it be? C. So 12 squared plus A squared equals your hypotenuse 15 squared. What's 12 squared? 144. So 144 plus A squared equals, what's 15 squared? 225. So subtract 144 from 225 and you get A squared is equal to 81. So what's A? So A is equal to 9. So I'm going to put a 9 right here. So now what's your sign? 9 over 15, and can that be reduced? Yes, it can. So you need to reduce it, which is 3 over 5. You find the rest. When you look at your sine, your cosine, and your tangent, do you think you'd recognize this triangle as being special? Yeah, it's a 3-4-5 triangle, which is a crack and triple, right? if you had recognized that from the start, you wouldn't have had to go through Pythagorean's theorem, right? Now this is all I do. I just find those three. Then what do? Flip them. So 5/3, 5/4, and 4/3. So you really only had to do work, well, this didn't require a whole lot of work, did it? So do B by yourself.
We don't have to put the leaders on. It's not the opposite.
No, you don't change the sign, correct. This is not fun, is it, right? Right. You like this one better?
I understand this.
So far. So what did you get for your other side? You got radical 11. So you do have to be careful and make sure you rationalize. So when you're finding sine, cosine, and tangent, rationalize. But when you go to flip it, well, you might not have to rationalize because it's not the hypotenuse, right? But on some of these, you will have to rationalize. Yes. This one here? I flipped the unrationalized form because that way I didn't have to rationalize it. So I will always look when I'm flipping something that has a radical in it. If I have rationalized it, I'll go and look at the one before I rationalized it.
You don't have to rationalize it, you just flip it that way.
If I flip this one, I don't have to rationalize it. If I flip this one, I would have to rationalize it, and who wants to do that?
Isn't it like the radicals on the numerator, but it's that
Correct.
way?
So this one I did not have to rationalize.
Yeah.
But when I flipped it, I did have to rationalize it. I'm not showing my rationalization. Is it okay that I did it in my head? Are you okay with that? There's a pattern to it, isn't there? Yeah. It gets a little bit more complicated if you're rationalizing to something that already has a radical, right? In the top, right, in the numerator. Yeah, because then you have to multiply it in there, and so these are not that complicated. Yes.
Do you have to do that?
You have to rationalize, yes. Yes, you do. So that's why it's handy to remember that 45 degrees is radical 2 over 2. Otherwise, if you look at the special right triangle, it's 1 over radical 2. So, all right, so then look down below at the special right triangle. So here they are. If I were you, I think that's the easiest way to memorize your unit circle. And we will finish our unit circle tomorrow as far as making sure everything's filling correctly. Aren't these two really the same? Aren't these two here really the same? Make sure you get your homework written down and maybe go and look at it. So technically you only need to have one of these, but you do need to remember that 45 degrees is pi over 4. 30 degrees is pi over 6, 60 degrees is pi over 3. And all you have to remember is you can either convert it with pi equals 180 degrees, right? Or take 180 degrees and divide it by 45. Doesn't it go in there 4 times? 180 degrees divided by 30, doesn't it go in there 6 times? 180 degrees divided by 60 is 3 times. So that can help you as well. All right, so flip this. So that's what I'm going to use for most of the rest of this. Special right triangles, because I, again, don't believe in memorization. Hate it. So the sine of 60 degrees is equal to the square root of 3 over 2. So if that, I have to find all the remaining trig functions. So they've only given me sine. I have to find cosine, tangent, cosecant, secant, and cotangent. So sine is what over what? Sine is what over what? So I know that this is opposite and this is my hypotenuse. So I'm going to draw my right triangle, and because it's 60 degrees, it's one of our special right triangles, so we don't have to do the Pythagorean theorem, right? And I'm going to put 60 degrees here. My side opposite is radical 3, so I'm putting that across from the 60. And since we're well aware of what our special right triangle is, isn't that correct anyway? Mm-hmm. And then my hypotenuse is 2. What's the other leg going to be? 1. Only because we know it's a special right triangle. Otherwise, we'd have to use Pythagorean's theorem to find that missing side. So now find sine. Well, we already have sine. So find cosine of 60 degrees. Tangent, 60. Cosecant of 60. So cosine is adjacent over our hypotenuse, so 1 over 2. Tangent is opposite over adjacent, so radical 3. And then flip these. So this one flipped is 2 over radical 3, but I have to rationalize it, right? So I get 2 radical 3 over 3. This one is just 2. And this becomes 1 over the square root of 3, which rationalized as radical 3 over 3. So isn't it a lot of what we did before? So far, yes? Okay. Are you okay with this? You're feeling better with it? Okay, because I felt a lot of stress before I left for the math conference. Just a little bit. Okay. All right, now we're going to evaluate this by hand. So far we haven't used a calculator. Can I move that up? Some of you are still copying. Well, don't you know the cosine of 45 degrees? But if you didn't, because you didn't memorize it, what would you do?
Look at yours.
Well, hopefully you know your special right triangle, right? So if this is 45 degrees, I know on my special right triangle that that means that this is 45 degrees, right? And this is 1, red 2. That you do have to have memorized. There are certain things you're going to have memorized. Yes. Because 45, anything 45, 30, or 60, those are your special angles. And those are all what's in the first quadrant of your unit circle, right? So those should be special numbers like perfect squares are, that kind of ring a bell in your head, goes, oh yeah, that's special. All right, so cosine, it's really 1 over the square root of 2, but if we rationalize it, isn't that rad 2 over 2? Now you do have to pay attention to what quadrant it's in. This is in the first quadrant, isn't it? So all students take calculus, all of them are positive in the first quadrant. Cotangent of pi over 4, that's also in the first quadrant, right? Cotangent is related to what? Tangent. So theoretically, cotangent is 1 over the tangent, right? But what we're going to do is find the tangent, we're going to flip it. So pi over 4 is what special right triangle? 45 degrees. So we're using that 45 degrees again. You have to know that pi over 4 is 45 degrees.
Oh.
So you have to look at the radian measure and convert it to its
Yeah,
degrees.
no,
So then I've got again 1, red 2. So if tangent is opposite over adjacent, isn't cotangent adjacent over opposite? The reciprocal, right? So what's the adjacent? 1. What's the opposite? 1, which is 1. Question.
Should I be negative one? Like on both?
No, because cotangent, pi over 4 is in the first quadrant. Isn't it?
Yeah.
Alright, so what do I do with my clipboard? Aha. Do you have a calculator?
Use your calculator.
Make sure you follow the directions there. Okay, so one thing that you probably should get in the habit of doing is go ahead and write the quadrant here. Because I do want you thinking, what quadrant is this in? Well, where's pi over 2? It's at 90 degrees here. We don't do a special right triangle for that. We look at the ordered pairs. So the other thing you have to have memorized are your 4 ordered pairs, but they're easy because the radius of this unit circle is what? 1. So what is this point right here? Not 1, 0, 0, 1. And remember that this is cosine and this is sine, right? It goes alphabetically. So cosecant is what? What is it, which is it related to? Sine. So sine is 1. What's the inverse of 1? 1. So then this one's also going to be 1. Yes.
Okay, so I'm just thinking, why is it, where would the hypotenuse be?
There, well, don't think that way. Because technically the hypotenuse is over here,
Yeah.
right? Yeah, so that's why we don't worry about doing a special right triangle for 90 degrees. Look at the ordered pair, because it's too difficult to think how you're thinking. It's much easier to look at the ordered pair.
So, just go cosine and sine.
Mm-hmm. Mm-hmm. Yes,
For cosecant, right?
yes.
Why would it be negative 1? Because that technically the opposite of 1 is equal to 1.
But it's not opposite, it's reciprocal. You can't think opposite, you have to think reciprocal or inverse. Those don't change signs, right? And if I'm looking at these two, if the sine of pi over 2 is equal to 1, then 1 over 1 is the cosine, right? Because I flip it. This is really 1 over 1, isn't it? And so then I flip it, and I still get 1 over 1, right?
So you don't change the sign, you just...
No, I never change the signs. The only time I change signs is when it's in a different quadrant. So the minute I move into quadrant 2, 3, or 4, that's when you're going to start to see some sign changes for some of these, right? Depending upon where x and y is. And that's why you have to write your special right triangle in the coordinate grid so you can see, oh, this x is negative or y is negative. So look at this. Now we're going to find degrees and radians. Again, no calculator. So sine of theta is 1/2. Where is sine positive? What quadrants? Find your unit circle. All students take calculus. Where is sine positive? Quadrants 1 and 2. So this could be in either quadrant 1 or quadrant 2, couldn't it? Right? I have 2 possibilities. So I have to consider that I might have 2 possibilities. So I'm going to draw a right triangle here and a right triangle here. It kind of looks like half of a bow tie, doesn't it? Why did I do that? Yeah, but that's because sine is positive in quadrants 1 and quadrants 2, all students, right? Then this is my opposite, and this is my hypotenuse, right? And this is where theta is, right here. Theta is always here closest to the origin. And this is my right angle. So if opposite is 1 and hypotenuse is 2, across from here is opposite, so here's my 1, here's my 2, across from here is 1, across from here is 2. Does this look like one of your favorite special right triangles? Which one might that be? Right, 30, 60, 90. So what would be here? Rad 3, and this would be negative rad 3, wouldn't it? But the whole purpose of this was for you to figure out, oh, okay, this is a special right triangle, so 30, 60, 90 right triangle. Which is theta, the 30 or the 60, and how do you know? Theta, is it 30 or 60, and how do you know? What's it across from? It's the 30 because it's across from the 1, isn't it? So, and technically this is 30 degrees from here to here, right? So all they're looking for is what is it in degrees? Isn't this equal to 30 degrees then? If you haven't memorized that the sine of the sine of theta equals 1/2, that theta would be 30, you don't have to memorize it if you just look at your special right triangles in your quadrants, right? All right, what about cosecant is 2? Cosecant is the inverse of what? Sine. So really what they've told us is sine is what? Sine of theta is 1/2, which means that theta is equal to what? 30 degrees, just like the other one, right? By the way, this is what theta was. So that one didn't require any work because we just did it for the previous one, right? What about secant? Secant is the inverse of what? Cosine. So cosine of theta is equal to what? 1/2. Okay, so this one is not necessarily 30 degrees. So remember, cosine is what over what? Adjacent over hypotenuse, right? And cosine is positive in what quadrants? 1 and 4. Look at this. All students take calculus, 1 and 4, right? So I'm going to draw my bow tie here. Only it looks less like it looks like only the right side of the bow tie, right? So here's my right angle, here's theta, and here's theta. So it says adjacent to theta. That means this side right here, isn't that 1? Right? And then your hypotenuse is 2. So this is 2 and this is 2. So what's this and this? This is one of our special right triangles. This is rad 3. And wouldn't this one be negative rad 3? Wouldn't it? Theta is across from rad 3. What's the degree measure? 60. So that means that theta is equal to 60 degrees. This is 60 degrees here too. It's just a negative 60 degrees. Same thing. All right, so then your sine on this one, does that look familiar to you at all? Sine is rad 2 over 2. If you've memorized it, you should know what it is. It is 45, but I'm going to prove it to you. Where is sine positive? Quadrants 1 and 2, right? So I'm going to make my little bow ties. And here's my thetas. Now this one's going to look a little weird though, because this is our opposite and this is our hypotenuse, isn't it? And this is where this can get slightly uncomfortable if you haven't memorized that 45 degrees is rad 2 over 2, because here you're going to be putting opposite radical 2 and then you're going to put a 2 over here, aren't you? Right? So if you haven't had it memorized, then that doesn't look familiar to you, does it? So what would you have to do to figure out this missing part? You'd have to use Pythagoras' theorem, right? And shouldn't you theoretically come up with radical 2? The problem is if you don't memorize this as being 45 degrees, you may not recognize that this is your 45-45 triangle because you've got side, side, and then the hypotenuse is different. When your side lengths are the same, your legs are the same, it doesn't matter what kind of triangle you have. Anytime your legs are the same, it has to be a 45-45 triangle, doesn't it? I mean, I could have 10 here and 10 here, and it would still be a 45-45 triangle. So you're going to have to recognize that. Theta is equal to 45 degrees. That one should be easy for you to memorize. It's the 30 and the 60 that you might get messed up, and the minute you put it in the special right triangle, you'll have it, and you'll go, oh, it's this one. Alright, now you gotta use your calculator. You have to pay attention to whether you are in degree mode or radian mode. If you are putting degrees in the calculator, your calculator needs to be in degrees.
How do you get to that menu again?
So go to mode. So here's your mode right down here.
Oh.
Hit mode, and right now my radians is lit up. Aren't I about to put 45 degrees in here? Okay, so I need to go down here and enter on degrees so degrees is flashing. So now I'm going to say second quit, and now I can put tan, whoops, not sine, try tan, of 45 degrees, just get in the habit of closing your parentheses. Now if you recall, 45, 45, 90 triangle, the sides are 1, 1, red 2. So tangent is opposite over hypotenuse, 1 over 1 is 1. We could have done that without the calculator, couldn't we? Yep. So your answer to this one is 1. So find the cotangent of 45 degrees. How are you going to do that? Just flip it, right? Or you can do 1 over 1 divided by tan of 45. You still get 1, only because it's 1, right? How do you do cosine of 5 degrees 40 minutes? Do you remember how to do the degrees in minutes? Where are they located at? So cosine 5, where's your degrees? What menu? App. So you have to do, you have to do second app so you can get to angles, right? There's your degrees. Hit 1 or enter. And then put in 40. Your seconds is also on that same menu, but it's at 2. And then end your parentheses and hit enter. Now I would suggest, they didn't say how many decimal places to go out to, but I'm going to suggest 4 places. So 0.995, is it stay a 1 or bump up?
On the apps.
Your apps is, do you see the math button?
Yeah.
It's right next to math.
Oh,
We're trying to get to angle above it because that's where all your angle stuff is. Do you remember where seconds key was in case you run across seconds? You had that on your homework, right? Where's the seconds key? Yeah, look at your plus sign, right? And it's right here to the right of memory, but what color is it in? Me, it's in green. Yours, it might be in a different color, white or yellow or something. But you have to hit the alpha button to get to your seconds. Why it's not in the angle menu, I don't know. I didn't put it there. I didn't put it together, right? Is it in the apps for the old calculator? Let me see it. Oh. For the older calculators, Amber pointed this out. This doesn't say apps, it says matrix. Is that, but you have the newer calculator. Yeah, so if you have the older calculator, the apps, our apps button is matrix. Thank you. All right, so then we want it in radian mode because look at what we're putting in the calculator. Pi over 3, isn't that a radian measure? So you have to go to your mode. You have to reset it to radians. So scroll down and highlight radians so it's flashing and then second quit. So now when I put in cosine, I'm going to find pi. You have to use the pi button, which is right above your caret button. Don't use 3.14 and then divided by 3. Close your parentheses, enter. What'd you get? 0.5, which is really 1/2, but you're going to put 0.5 because pi over 3 is what degree? Bless you. Pi over 3 is 60 degrees, and what did we find the cosine of 60 degrees was in everything that we've been doing here? Yes. Are you in radians? Let me see your calculator. Let me see what you put in. You got that too? I'm pretty sure you're in degrees, but let's just check it. So that's what he got. If I go to his mode, you're in degrees. See how it's lit up? So you got it. You have to scroll down and hit enter. So it's flashing. And so now do it again. Try it again. Yep. And you're going to have to do that in your homework, change back and forth. And so if you get a wrong answer, just double check and make sure that your calculator wasn't in the wrong mode. And so for cosecant, what are you going to do? Yeah. So cosecant is really 1 over sine of 4 pi over 5, right? So that's what you're going to put in your calc. 1 divided by, and then you probably won't need it. Sine of 4 pi divided by 5. Make sure you end your parentheses. If you don't, I can't guarantee what it'll do. What'd you get? Does the 3 stay the same or bump up? It stays the same. So 1.7013. So that's just a matter of going back and forth in your calculator. Then we're going to find theta with our calculator. So we're going to use our inverse button. So now we're going to start to use the inverse sine, inverse cosine, inverse tangent.
Should this be in radians?
Well, there's the question. See how I'm going to I'm going to have one problem. I'm going to do it in degrees. I'm going to do it in radians. If I want degrees, I need to have my calculator mode in degrees. If I want my answer to be in radians, my calculator mode needs to be in radians. When it gives you the radians, it's not going to give you, pi over 3. It's going to give you the decimal equivalency of that radian. Question?
Just to go back to the other ones.
Yeah.
I remember you were saying that when we were first in 5 minutes, I remember you were saying something about seconds. If I get to it.
Yeah, your seconds is above your plus sign on your calculator to the right of memory. Do you see it? Yeah, those little quotes, that's the double quotes is seconds. Yep. All right, are we all ready to go on this one? Okay. So first thing, if I'm going to do degrees, I'm going to make sure my calculator is in degree mode. So go to mode, scroll down, highlight degree, and you've got to hit enter. Make sure it's flashing. Then second quit out of that. Now you're ready. So put in inverse sine. How do you get to inverse sine? Okay, so second sine. Think of it this way. You're finding degrees, right? You remember your trig table where you had all the degrees and then it had 3 columns, one for sine, one for cosine, and one for tangent? And it gave you all these 4-digit decimals? That's using the table the correct way, is you find the degrees and then you look for the 4-digit decimal. Aren't we going backwards in our table? So we're kind of going backwards here, and I'm going to show you theoretically the algebra behind it in just a minute. So put in your 0.81. You're in degrees, yeah, because we're finding degrees of theta. So if you want degrees of theta, your calculator needs to be in degrees. All right, so then hit enter. Round to 2 decimal places. What do you get? 54.99, right? Put a degrees on that. Make sure if you're answering theta in degrees, you have degrees with that. Then theoretically, so I want you to write here, in theory, so in theory, this is what we're doing. We have sine of theta is equal to 0.8191. That's the problem that was given to you, right? Technically, if I want to solve for theta, if you want to look at these as being multiplied, they're not really, but if you want to look at them as being multiplied, I would divide by sine, wouldn't I? Would I divide this by sine? Okay, and isn't this sine to the first power? Are you with me so far? So theta is equal to, if I want to take this sine to the first power and move it up into the numerator, what happens to the exponent? Doesn't it become sine to the -1? And then times 0.8191? Okay, technically that's not what's going on, but theoretically, can you understand why we're going to use that inverse sine? Okay. Do you get the same answer if you did... Now, I haven't given you... The other day, we were doing some sort of problem where we were doing cosine, and you had the degrees right here in either theta. They either gave it to you in degrees or radians, right? And you couldn't use the inverse sine for that, correct? Do you remember we tried to do that the other day and it didn't work out? Mm-hmm. It's because you knew what theta was. You were given theta in degrees and or radians, and you knew what theta was. You cannot use the inverse sine for that type of problem. If you don't know your degree measure, that's when you can use your inverse sine, cosine, or tangent, okay? So, do your radians. It's gonna be the same thing, but we're gonna use, our calculator has to be in radians. So go back to mode, highlight radians, you're gonna get tired of it. Back and forth and back and forth. Second quit, and now do the same thing. Second sine, so you get that inverse sine, and then 0.8191, closure, sine, and did I get a different answer? Yes, but this time this is in radians, and we're gonna go out to, let's go out to 4 decimal places. So 0.959, what? And I want you to put a rad at the end of that so that in your brain you realize that that's rads and the other one was degrees. So far not so bad, right? Okay. Now we have identities. Yay. So this is on that sheet of paper that I gave you. You've got to memorize all those. Sorry. I fought it, because I hate to memorize. I really fought it. But once you get over the irritation of having to memorize it, you can start to see patterns that make sense to you. So you are gonna have to memorize it. So take some time before you take this test. Start memorizing now. All of this. All of this. There are patterns in there. I mean, I could give you what makes sense to me, but, you know, your brain, you should know by now how your brain works best. You figure it out. Put it on flashcards. Whatever it is you need to do, do it. So we're going to do essentially, kind of like a proof, but you don't have to write your reasons why. We have to take this, and anything above here, we're going to use any of these equivalencies. And we can replace things in this equation so that we get the left side equaling the right side. Not everybody will have the same answer. Now, having said this, if you have 1 on one side of your equation, I would like you to try to do 1 equals 1. Okay? This one you'll see where I don't end up doing that way, but if I can follow your math and you have to show everything, then I will accept it, so long as you get the same side equaling the same side. So for this first one, I'm going to do it 2 different ways. So, way 1. Cosine times secant. Now, aren't cosine and secant somewhat related to each other? Right? Aren't they inverses to each other? So way 1 might look like this. I'm going to take the cosine and leave it as is, cosine of theta, but I'm going to put it over 1. Because these are being multiplied, that's times. But I'm going to change the secant into something that has cosine in it so I can make the cosine cancel out. What's the equivalence of secant with a cosine? Secant of theta is equal to what? 1 over the cosine, isn't it? So can't I replace secant with 1 over the cosine of theta equals 1? Would you agree that I can do that? Do you see why I did that? Because I'm trying to get 1 on the left side. Don't these cancel now? And don't I have 1 equals 1? That's my whole goal, right? Now let's do way 2. So way 2, this time I'm going to change the cosine. What's the cosine in terms of secant? 1 over secant. So 1 over secant of theta times, I'm going to leave secant alone, secant of theta over 1 equals 1. What was the purpose of that? So my secants can cancel out, right? What do I have left on the left? 1 equals 1. My goal was to get 1 equals 1. So that's your very simplified form. This next one's a little bit more complicated, and your algebra is going to come back to haunt you. Ignore the fact that there's secants and tangents in there. Just ignore that fact. Something plus something times something minus something. Doesn't that look familiar to you? It should. Thank you. Isn't that the difference of two squares factor pattern? If this were A plus B and this were A minus B, do you see it now? Do you see it now? So doesn't that multiply as A squared minus B squared? What's A in this case? Secant. So if I multiply this out, don't I have secant and we put a little squared here in front of the theta? And then minus, what's our B? What's B? Tangent. So I have tangent squared theta equals 1. And then look up here. I've got secant and tangent. Do you see in the Pythagorean theorem part up here, I've got secant and tangent? A secant squared equals 1 plus tangent squared. If I can get one side to be 1 plus tangent squared, I can replace it with secant squared.
So just add this tangent squared.
Yeah, I'm going to add the tan squared to both sides. So I'm going to add that to both sides, and I end up with,
Please excuse this interruption. Those students who normally ride bus 109 will ride bus 120. Just for today.
so
Those who
can't,
normally ride bus 109, please ride bus 120 today.
can't I replace the 1 plus tangent squared with a secant squared, according to Pythagorean theorem, identity above, right? Don't I have the left side equaling the right side? That's my goal. Now, somebody might have tangent squared equals tangent squared, and that's fine. I could have done it that way as well. All right, I'm gonna leave. Say that again?
Actually, I don't know if this matters, but I did one with
I'd rather you didn't do that, although you could have. I'd rather you get down like one thing if you
Yeah.
can. All right, I'm gonna do this last problem here tomorrow. The angle of depression, angle of elevation, your assignment's there. I don't believe it's on that assignment, but I could be wrong. If it is, just skip it until we go over it tomorrow.